Welcome to another stream, and we're actually back to back 2 days in a row. And the reason being is, well, I'm going to actually travel tomorrow for work, and I'll be unavailable for about 3 days. So I come back. I think it's Friday. I come back on Friday, so I can only stream on Friday for you guys, which means I need to get some streams out this week, and I've got some shorts also ready for later on this week. So my YouTube algorithm doesn't penalize me for being inactive, right? So that's why I'm doing all this. But welcome. It's good to see some of you. I've realized that. Oh, hello, Vinay Sharma. Sorry, I didn't realize that the chat wasn't loading, but we're good now, right? Yeah. So yeah, good to see you. Good to see you, Vinay Sharma. It's been a long time indeed. And Slim, thank you for joining, guys. Make sure you hit that motherfucking like button, and I should really not swear as much because we got good news. I think we're YouTube partners now, which means we get adverts on our videos. Yeah, that's always good, but that means I also have to probably stop swearing as much in my lives. Slim, maybe Rust and C++ will be with you. Oh, don't swear. Yeah, indeed. So yeah, I mean, excited to try this out. So today I thought, why not? Let's try something new, something that I don't actually have to pay attention to, because I'll probably not be streaming for too long, probably like 2 hours or something. So I've been hearing a lot about Mojo. Mojo, for those who don't know, is this sort of like AI language that kind of resembles Python a little bit and should be sort of interoperable with Python code. And people claim that it's very fast, so that's what we're gonna find out today, right? We're gonna run some code in Mojo, and perhaps we can like benchmark it, right? So yeah, I mean, plan for today is install the SDK. We can probably read the introduction here for a bit just to see what it's about. Install the SDK, try and compile a few Hello World programs, and then maybe we can try something a bit more complicated, like, I don't know, calculating Fibonacci numbers or something like that, and then we can benchmark that with the same program written in like C++ or Rust, and we'll see like if it's really fast or not. I'll be actually interested to see what kind of binary this compiler here will spit out, right? Because that's what that's how I want to benchmark it. Basically, just compare it to a C++ compiled program and see how much blow it actually adds to the end program. Susie Tags, hello dude, welcome to the stream. So let's get started. So let's read a little bit about this and see if we can like get what this language is about. So when we started modular, we had no intention, and this song is pissing me off now. I don't know why it's like cutting off as well. Or I cannot play any Legend of Zelda songs because I keep getting kind of copyright striked. I'm not sure about this one. Yeah, maybe this one. I'm going to turn it off for a bit there. So when we started modular, we had no intention of building a new programming language. But as we started building our platform to unify the world's ML AI infrastructure, we realized that programming across the entire stack was complicated. Plus, we were writing a lot of MLIR by hand and not having a good time. I guess the MLIR is kind of like a machine learning language for like NPUs or something. I'm not entirely sure. Also, like, I've never heard of modular, even though I technically worked in machine learning for like over a year. The guys at my work were just using, I guess, other frameworks to run neural nets on devices. What is that? MILR? Is that what it is? LR? Kind of interested now. MLIR. What is it? Oh, it's MLIR. My bad. MLIR. Multi-level intermediate representation overview. Is a novel approach to building reusable and extensible compiler infrastructure. MLIR aims to address software fragmentation, improve compilation for heterogeneous hardware, significantly reduce the cost of building domain-specific compilers, and aid in connecting existing compilers together. Do you guys ever read, like, when you go to a product website or a frameworks website, and then you read like the first few paragraphs where it's supposed to explain what it does, and you just end up more confused than you were before because they're not saying shit in this. That's how I feel with most most like introduction documentation to different frameworks. But yeah, what is it actually though? Let's see if we can figure it out. Oh, MLIR. All right, so is it the intermediate representation of like compilers? Is that what LLVM does basically? I know what LLVM does. Yeah, okay. Let's just assume it is that. Anyway, so they were writing a lot of that, and they decided to create this language to not have to do a lot of that. So what we wanted was an innovative and scalable programming model that could target accelerators and other heterogeneous systems that are pervasive in the AI field. So this is an interesting sentence here. So they wanted a programming language that could target all the accelerators. And if you don't know accelerators in machine learning, I assume it means like the NPUs, right? It's like there are different, there are new processing units just for machine learning stuff that can run like basically neural nets, right? And part of my job at Microsoft, I'm not sure if I can say too much, but I'll say the overall shit, was just basically implementing this backend that would take in a neural net and run it on whatever NPU for the device that we support is. So for example, for the Qualcomm devices, we had SNPE, Snappy, which is its own framework to run neural nets on the Qualcomm enabled machine learning devices, right? And we also had things like OpenVINO, which does it for Intel. So each kind of company that seems to be supporting, that seems to be developing these NPUs, they seem to have like a different framework each. So I guess that's what they mean here by they wanted to have different language that could target all of these things. I just go for this code examples. Yeah, Slim, I just go for the code examples too. Dude, I'm not sure if it's me or you, but your delay must be like delayed as hell. That was like 20 minutes ago. But anyway, so they want something to minimize the work they have to do to support multiple accelerators. And then, okay, that's cool. That's cool. So let's look into the intro and see what we can find here. Now let's get the music back on. I'm gonna turn it down a little bit. Oh yeah, I just fast forwarded. Yeah, you didn't miss much, dude. Just chatting stuff. So Mojo is designed to solve a variety of. Yo, why the hell is like my Spotify just like randomly stuttering? I'm not sure if you guys can hear it on stream as well, but it's hell of an eye. Let's see if it improves now. Yeah, I've no idea why it's stuttering so much. This usually happens when my CPU has been used by multiple things, but I think it's fine now. Yeah, it's alright. 30% usage. It can't be my headset, can it? Let's try it out. See if we can improve that. It might be my headset. I'm gonna turn it off and on again, the usual. So it sounds like something being shuffled. Yeah, it did, didn't it? I'm not sure if my headset's causing it or Spotify is just like bugged for some reason. Let's try again. Oh no, that do not want that on top all the time. Spotify. Oh no. Yeah, it was definitely my headset. This says it's connected, but I can't see the device. Damn Windows! Why must you have so many bugs? There you go. Should you connect it now? Let's see. Transparency mode, 75%. I think is the mic. Oh, I see what you mean. So you're getting some. Ah, yeah. So I'm not saying anything. Then I guess you're getting some shuffling stuff. Like, how bad is it? Let me see. Testing 1 2 3. Testing 1 2 3. Always 2 3. Testing 1 2 3. Shuffling stuff. Like, how bad is it? Let me see. Testing 1 2 3. It sounded okay. Testing 1 2 3. Ah, is the mic. Yeah, it sounded okay though. I mean, the problem is I have like a bunch of filters here, so I don't know which ones I have to change now. Usually that would be like the noise reduction. That's the behavior you see there. Noise suppression. Maybe we can suppress anything that's like less than 20. Yeah, what the hell is that? I don't understand. I believe it's probably the compressor. Yeah, it will be the compressor somewhere. I mean, I'm not going to be able to sort this in this video, in this stream. Está ok por aqui o som. Obrigado, José. So Jose says it's okay. Maybe when we turn on the music, you guys can't like hear it as much, I guess. So, but anyway. Yeah, we're back now. So, yeah, I mean, if it's really bad, do let me know. Like, I'll have to fix it, I guess. It's because, like, the problem is my microphone is right next to my laptop, which has a really, really loud fan. So, you know, that's kind of what you can see here. I mean, Lenovo has this BIOS settings where I can kind of reduce the noise on my fans. So maybe we can try that. Maybe that'll stop everything. So instead of performance, we go on quiet. But then that brings the CPU usage like right down, which means you guys might not be able to. I don't know, it might not be as responsive as usual. But yeah. Yeah, anyway, going back to Mojo. Welcome to the Mojo Manual, a complete guide to the Mojo programming language. Mojo is designed to solve a variety of AI development challenges that no one else can, because Mojo is the first programming language built from the ground up with MLIR, a compiler infrastructure that's ideal for heterogeneous hardware, from CPUs and GPUs to various AI. I don't know what this is. I mean, these are just like letters to me now. I know AI, I know what a GPU is, but what the hell is that? We also designed Mojo as a superset of Python because we love Python and its community, but we couldn't realistically enhance Python to do all the things we wanted. For a longer discussion on this topic, read Why Mojo. I will not read Why Mojo because I don't want to waste too much time, but yeah, cool. I guess they're trying to do something like what TypeScript is to JavaScript, but with loads of like ML on top of it. So yeah. Has anyone in the chat actually used Mojo before? That's my question. Because like I seem to every odd post on Twitter is just about Mojo now. Like that's why I'm doing this video, by the way. I don't want to miss out on the wave, but yeah. It's been talked about quite a lot. So let's get started. Get Mojo. Mojo is available for local development. The Mojo SDK is currently available for Ubuntu Linux systems and macOS systems running on Apple Silicon. Support for Windows is coming soon. So Windows is not supported. What a shame. No, you've never used this, Lim. Cool, yeah. I don't think many people have. You can also develop from Windows or Intel macOS using a container or remote Linux system. Alternatively, you can also experiment with Mojo using a web-based Mojo Playground. Ooh. Oh, so that's like a Jupyter notebook kind of thing that they've got. Ah, I don't want to create an account just for that. Let's just download it into our systems, right? So get the SDK, the Mojo SDK. The Mojo SDK includes everything you need for local Mojo development, including the Mojo standard library and the Mojo command line interface. I guess the compiler, right? That would be a good start. The Mojo CLI can start a REPL programming environment, compile and run Mojo source code, Mojo source files, format source files, and more. I hope it's like Python with brackets. I don't. Yeah, nah, no brackets, dude. Look at that shit. No brackets. It just looks the same as Python, to be honest. Yeah, even the for loops here don't have brackets, so you're still stuck to properly indenting things for the win. Fuck my life, it's not. Yeah, it's not, dude. It's not. I mean, it's Python. It's just Python in a mask. We've also pushed a Mojo extension for Visual Studio Code to provide a first-class developer experience with features like code completion, quick fixes, and hover help for Mojo APIs. Cool. Maybe we'll install that. I bet like for companies are already like hiring Mojo developers and they want 15 years of experience though, don't they? Would not be impressed. Right, let's see if we can install this shit then. So download now. Wait, I have to log in to download. They really want my email account, don't they? Jesus Christ. Alright. I just hate it when you have to like create an account to download something. Like sudo apt update, get install modular. So modular seems to be like a massive thing because like I've never heard of it, but it seems to be on the freaking Ubuntu repository already, on the apt repository. Mask your email, bro. I could do that, yeah, but the thing is like it's already in so many places online. I can just not do that basically. Like it's on my LinkedIn, it's on my website, it's on my CVs, which it's kind of everywhere. I don't care too much if people message me on my email. I can just kind of block people if they're being too annoying. But yeah. The thing is, I mean, if I start getting death threats or something, then yeah, I'm sure I'll probably create a new email and start using that instead. But you guys are kind of nice, right? It doesn't seem like you are gonna threaten me in any way. So install modular. Modular's not here. Oh. Sudo apt get install modular. Wait, what? So they've got something to install via apt here. And then, okay, let's use this one, I guess. Would you block me if I send email saying hello? Suzy tags, I'll block you. And I'll block you from Discord as well. I'll make sure I block your children. Just while I'm at that as well. So yeah, don't do that. But yeah, dude. I mean, no, I won't block you, but please don't. Like, you can just say hello here. You're wasting your time if you send me an email. Yeah, so the apt stuff doesn't work. But I guess there is a nice little CLI thing here. So, okay. Welcome to the modular CLI. Okay, so somehow this is very like invasive. It installs to my stuff or to my path already. So where is modular? Okay, yeah, system install. Nice. It would be nice if they didn't install it to the system bin. All right. Then modular install Mojo. Let's do that. So firstly, you have to get modular, which seems to be like some sort of like framework for running neural nets or something. And then you have to get Mojo through that. So that sounds good. And there's a pip output. It looks like pip, very much looks like pip. Yeah, this is basically pip, yeah. Yeah, let's click on get started with hello world here. Okay, so now let's go into development. Actually, this is not as important that it grants a directory, my development directory. So I'm gonna create it in my temp directory because I don't think we're gonna do anything with this. Let's go into Mojo test and then. Right, hello world. After you install Mojo, you can use the Mojo CLI to build and run Mojo programs. So let's create the classic starter program that prints hello world in 3 different ways. Cool. 3 different ways. Why can you say, okay, right. You must set the modular home and path environment variables as described in the output when you run modular install Mojo. For example, if you're using bash or z shell, add the following lines to your configuration file. Okay, so do I not have, did that script install it for me already? I don't know. What is it? Modular home. Oh, homey, home. There you go. No, we don't have that. Yeah, let's do that. So Z C, and then let's go right to the end. Oh, Tailwind stuff is still installed here. Didn't realize. So export modular home. Oh, home. Oh, home, and then modular. We got path, and then what do we have here? Modular home, right? Wait, what? Packages. It's not just modular home. All that shit here. Now if I do an echo modular home, does it modular? Good, so right. I've got the path there. Do we have Mojo? Yeah, we do have Mojo. Nice. And to quit, we do this as well. Right, run the code in REPL. I think we just did that, right? So if we just run Mojo. Does it have like a help thing? Nope, it doesn't. Help? Like in Python? No, it doesn't. So print hello world. Let's try that one. Print hello world. What's this 2 thing? It's so annoying. Like, why does it not just take that as the as the thing to execute? Anyway, yeah, we're not interested in this, so let's quit. Let's run a Mojo file. Now let's try the code in the Mojo source file and run it with the Mojo command. Create a file named hello mojo or hello.fire. What is this? Why? What the hell? This is definitely what we're going to use though. Why did they pick fire anyway? So many better like emojis to pick. So yeah, let's run this with code. Right, let's create a new file here. Oh, new file called hello. Wait, I actually want to see if this actually works because it better freaking work. Hello.fire. What the hell is this? Who thought that this would be a good idea to put in the language? Like, you're just shooting yourself in the foot. Anyone's gonna try and like port this to an older platform or something that doesn't support emojis, and they're gonna have a hard time. Anyway, so we've got function fn for function main. Okay. Wait, do we have the Mojo thing? Mojo language support. Yeah, why not? Does IntelliSense work well? Print a string. Yeah, if I do an F12, I can't actually look into how it's implemented, but cool. And then we just run it with Mojo hello, right? So if we open a terminal window, hoping that you guys can see it very well, let me know. If you can't, we can do Mojo hello.fire. Okay, does this compile my code? It does not compile my code. So Mojo build compiles. Mojo build hello.world. So you have hello. Now, how big is the file size here? We've got 3.9 megabytes just to say hello world. Interesting. 3.9 megabytes though. That's crazy. Now, if we do Mojo build and help. What can we get here? Can we build it in, for example, debug? Because I want to see what kind of source code this is going to generate for me. What kind of, I guess assembly, sorry. I was just checking a text message. Sanitize, target compilation options, no optimizations. Disables compile optimization. This might reduce the amount of time it takes to compile the Mojo file. It might also reduce the runtime performance. We don't want that. By default, the executable is saved to the current directory and named the same as the input file without a file extension. So key value defines a named value that can be used from within the Mojo source code. Okay, cool. So do we have debug? I guess sets the debug sets the language to emit as part of the debug info. Wait, what? Debug level sets the level of debug info that's used at compilation. The value must be one of none, line tables, or full. Please know that there are issues when generating debug info for some Mojo programs that have yet to be addressed. Interesting. So it doesn't fully work to compile something for debug, I guess. Some stuff. But anyway, we've got this here. I want to turn this into assembly. So how do we do that? So is it object dump? As a binary to assembly. It's object dumping something, right? Oh, how to disassemble a binary executable. Okay, right, let's try that. Object dump -d, that will disassemble it. So that will basically read the binary, if you guys don't know, and then spit out the assembly code. So basically just translates it to assembly. It's a disassemble thing. So object dump -d, hello. Jesus Christ. You see how big that is? That's a lot, that is a lot. Anyway, let's save that to a file. So assembly.txt, right? So we have assembly here. And this is the source code that I created for me, right? Oh, sorry, the source code. This is the assembly code that I created for my simple print hello world. Now, in comparison, let's see what happens when you do the same thing with C++, shall we? So if you guys are interested in knowing this kind of stuff, godbolt.com, godbolt.org actually, or the Compiler Explorer, is a very good tool that you can have in your arsenal, and as long as you have a web browser, you can put in some C++ code here, and it will show you exactly what kind of assembly something will generate, right? So for example, if we look at Clang, let's look at the Clang compiler. Clang. There you go, x86-64. Yeah, where is it? We don't want the ARM compilers. Let's just get the... There you go. The latest Clang compiler. And we have C++ set to 23, as well as something like 03 optimizations are the highest. Which I'm not sure this is what this did. If I look at Mojo build help here. What is this? Sounds like some pleb music, not gonna lie. Like you're ready to just go into an old pub and have chicken and whatever, and gravy on top of it or something. Yeah, optimization, where is that? I remember reading that somewhere. Debug level, sanitize. Does it really not have no optimizations? Oh, 0, okay. Oh, so by default, I guess it does have optimizations enabled, right? So I guess it probably has something like 02 or 03 or whatever the equivalent is. But anyway, let's look at the C++ equivalent to that, right? So can you guys see this? And I hope you guys can. I'm gonna zoom in a little bit, just in case. There you go. So see out, hello world. Let's use endline, why not? Actually, let's just put it straight here. And that is it. So with O3, this is what Clang 17 generates for me for a Hello World program. Like 11 lines of assembly. And I'll compare this with the supposedly really fast and safe language. We have quite a bit. We've got quite a bit, right? This is so much. I'm surely doing something wrong here with the object dump command. It just can't be this much. Unless it's like loading in the whole runtime just to run a print hello world function, and it's not actually running all of this code, it's jumping into. But anyway, yeah. Not looking good so far, not looking good so far. Now let's continue. Build an executable, we've done that, gone and done it. Next steps. If you're new to Mojo, we suggest you continue to the next lesson, language basics. Let's do that. We're going to learn enough so we can do like a Fibonacci number generator. And then we're going to compare that to C++ and Rust and see if we can even benchmark it, right? So I bet you guys all better be installing this right now and following with me. This is a lesson. At this point, you should have already installed this, have already set up the Mojo SDK, which we did, and run the Hello World program. Now let's talk about how to write Mojo code. You probably already know that Mojo is designed as a superset of Python. So if you know Python, then a lot of Mojo code will look familiar. Great. However, Mojo is first and foremost designed for high performance systems programming. With features like strong type checking, memory safety, next generation compiler technologies, and much more. Like so far, I've not seen this bit here. I've not seen next generation compiler technologies such as optimizations. Not doing a great job at that, at least. Strong type checking, we've not had enough time. Yeah, memory safety, again, don't know much about the language to know it. As such, Mojo also has a lot in common with languages like C++ and Rust. Yeah, we've designed Mojo to be flexible, so you can incrementally adopt systems programming features like strong type checking as you see fit. Mojo does not require strong type checking. Okay, I'm not sure if I like this one too much. You either are a language that requires strong type checking or you're not. Static types are useful. Yeah. I wish, if Python had strong type checking, and you had things like types for the arguments of functions and stuff like that, it would be so much easier to kind of read Python, in my opinion, and not get into really bad pickles where you pass in a value thinking is the right type for the argument, and then down the stack it just fails because you passed in like a list instead of a string or something like that, right? But anyway, on this page we'll introduce the essential Mojo syntax so you can start coding quickly and understand Mojo code as you encounter it. Subsequent sections in the Mojo manual dive deeper into these topics, and links are provided to you. Okay, cool. I'm not going to read the whole thing. I mean, I don't want to take too much time. So what do we have here? Function definition. So Mojo functions can be declared with either fun or def. Okay, I mean, the fn declaration forces type checking. Okay, and memory safe behaviors, Rust type. While def allows node type declarations and dynamic behaviors like Python style. So for example, def function does not require the declaration of argument types or the return type. Okay, cool. But this one does. So what I can see here is that we're going to use fn all the time, right? It's just the best alternative. Both functions have the same result, but fn function provides compile time checks to ensure the function receives and returns the correct types, whereas the def function might fail at runtime if it receives the wrong type. Cool. Currently, Mojo doesn't support top level code in a .mojo or .fire file. So every program must include a function named main as the entry point. You can declare it with either def or function. So how do you create modules in this? Is it not possible yet? That's my question. Cool. Variables, let's see. I'm not going to read the whole thing. So you can declare variables with var or with let. I mean, so far I'm seeing a lot of you can declare functions like with def or fun. Cool. I mean, in that case, I understand that you've got two different behaviors there. And now you've got var and then let. Oh, let is to create an immutable type. Cool as well, but like, why can you not just have one of these and have something else to differentiate whether it's kind of a mutable or immutable variable? Kind of like Rust, right? So let mute, it's kind of a mutable variable, and if let is just automatically immutable. Anyway, yeah, seeing a lot of like options here. So def do math, cool. All right, so if we were to write our kind of function to do the Fibonacci, what are the types here? So this is def, okay, structs. I want to look into function real quick. Okay, so we just put in, we pass in the type in like that. So end Fibonacci int is int a thing, okay? And then we can do whatever here, right? So we can do an if statement. I'm just gonna like speed run this. Let's speed run this shit. Wait, what's ifs? Variables, structs, conditional values anywhere? No. Language basics. Is there an if here? We'll take a look at structs in a bit. Okay, if, okay, so just the same as we know. So int. Why is int not happy? Cannot form a reference to overloaded declaration. Oh, okay. We've stumbled across a problem, so. I don't know what this means, but we'll find out. So if n is equals to 0, return 1, right? Or if n is equals to 1, we return 1 as well. You know, fairly typical Fibonacci shit, you know, what you shouldn't really write it with. So we can obviously cache this in the future, but yeah. And we're going to return Fibonacci of n minus 1 plus Fibonacci of n minus 2 here. Now, what is the issue here? Could not find built-in int literal type Mojo. Right, cool. That's interesting. I don't know what this means, but where's the do math thing? So we were here, we had like a do math. I can't use literals. Why can't I use literals? That's the question here. Maybe int is not the type we're supposed to be using, you know? Is there like a types kind of documentation page here? Oh, we've got some nice libraries here already. Oh, it's int capital, nice. Right, so what is the issue here? And we have to return int as well, right, I guess. Ah, okay, that's better. Okay, so far looking very much like Rust. Very much like Rust. In fact, this is the same code that you'd write for this function in Rust, except obviously the int, you'd have something like an i32 here or something like that, right? Cool. I mean, I still don't know what the type int, this type represents an integer value. I don't know how wide this type is, if it makes sense, like how big this type is. What is the maximum number I can write with this? I don't know. But anyway, so let's print the, well, let's let our fib, right, be the Fibonacci of, I don't know, 20, right? 20 is good. So let's do a print. Does printf work? Printf? No, no, that would be too good, right? If printf was available, that would be too good. So let's see if there's a kind of like an output thing in here. So Mojo libraries, module index. Wait, what? These are all the modules in the Mojo standard library. Cool. How do you import them though? That's the thing. So let's skip to that part of the tutorial, modules and packages. So Mojo provides a packaging system that allows you to organize and compile code libraries into importable files. Are you guys bored yet? I can tell that you guys are bored. This is too much, isn't it? To understand Mojo packages, you first need to understand Mojo libraries, Mojo modules. A Mojo module is a single Mojo source file that includes code suitable for use in other files that import it. For example, you can create a module to define this. Okay, but I thought, notice that since this code has no main function, so you can't exclude. Wait, notice that this code has no main function, so you can't exclude my module Mojo. Can't execute my module. I can't read today though. Can't read today at all. However, you can import this into another file with a main function and use it there. Cool. So is it just the same as Python? Yeah, same as Python for importing. So if I do import here, what do we have? Oh, we've got quite a lot of stuff. Sys, tensor, times, hello. So you can import itself apparently. Oh, nice. What's in the runtime? Oh, we don't want to trace. I'm looking for something like IO, OS, what's in OS? Windows Atomic. Nah. Python integration. So import a module path. Import a Python module. To import a Python module, you can just call Python import module with the module name. Wait, what? This is really cool. So if you've got like Python with NumPy and OpenCV installed, you can run those from Mojo. That's amazing. That's actually really cool. I mean, they do claim to be interoperable with Python, right? So. Is the chat messed? Or are you guys just not sending messages? That's fine. Maybe we should open Discord as well, just in case. Yeah, cool. No, I think the chat's fine. I've got to make sure it's working because sometimes it doesn't update. See, I'm losing my thought here. So yeah, you can import my Python modules, that's cool. But where is printf? I mean, we don't have printf now, but we can do fib. Should have been our Fibonacci. And we don't want that. We don't want printf now. So Mojo build hello.fire. Cool, I mean, nice. Now let's see how long it actually takes to do Fibonacci of 50. Dude, we can't play Minecraft music. Just against my morals. Yeah, so we know Fibonacci of 50 is going to take a long time, it seems, which is fine. I feel like, you know, writing the same program in C++ is still kind of doable, right? It still finishes eventually. But this is, oh, there you go, it finally finished. So the 50th Fibonacci number, that's right? We didn't just misroll the... Misroll the thing. So where's the 50th? The 50th Fibonacci is this 025, 12, 025, right? And what do we have? No, this is not right. What have we done? What have we done? Right, let's try and take in an argument here in the function. I don't know how to take arguments in, right? So let's see how we can do that, because then I can pass in the number, the index to find the Fibonacci for at runtime. So yeah. Value ownerships. Which one of these is more likely to be what we want? So it's not hello world. We've been here. Language basics, maybe. Read. Nope, no reading here. Functions, variables, structs, metaprogramming, Python. When calling Python methods, Mojo needs to convert back and forth between native Python objects and native Mojo objects. Most of these conversions happen automatically, but there are a number of cases that Mojo doesn't handle, yeah. Okay, I mean, this is not interesting to us right now. What we do want is there's ray tracing Mojo. That's really cool though. Oh, it's big. It's a big project. It's a big project. Utils, maybe we have it here. Index implements static int tuple, which is commonly used to represent ND indices. Cool. No, none of these will help us. Time testing, sys random. Is that random number generators? I guess it is. Foreign function interface stuff. I'm just looking for like a read, right? What's in sys? Sys arg. Ah, okay, so we've got the arg values here. Okay, so that's one way of getting it. So sys import sys, from sys import argv, right? So we can now use it here. So argv. What type is it? What is this type? It's a variadic list of string references. Okay, so we can let our n be this argv of 1, right? Argv expects 0 input parameters but has 1 specified. Oh. What? That's interesting. If I just print argv, no matching in call to print line. Okay. Wait. What is arg? Is this not how we get the system arguments? I'm gonna have to Google it now. Mojolicious, what is this? Mojolicious commands is the interactive command line interface for Mojolicious framework. It will automatically detect available commands. Okay, I mean, I don't know what this is, but compile time, metaprogramming. Mojo command line execution configuration. No. As Mojo is an extremely new language, I want to keep track of the development and try to... Okay. File opening seems the same. Wait, what's this guy saying? Writing a lot of Mojo code and it feels like writing C on hard mode. What, dude? No dick-like structures. Oh yeah, I guess. Cool. I see what you mean. File I/O is super rudimentary. Docs are very sparse, etc. It's actually very fulfilling though. So this person is saying that, I guess, I/O is rudimentary. So I'm finding it non-existent, to be honest. I can't see the freaking file I/O here. Not file I/O, but just I/O in general. Mojo I/O. Dude, all I'm trying to do is write a Fibonacci function. Please tell me I'm going to be able to do that in the stream. Oh, what is this song, please? No Legend of Zelda. There you go. A little bit better. Yeah, I can't see anything on like kind of passing the system arguments into. Implement functions and variables for interacting with execution and system environment. Arg.argv. What is argv now though? It says that it's a variadic list. So it's a list. Okay. Collections. Let's look at variadic lists, shall we? What is a variadic? There's no variadic list in the first place in here. That's interesting. This is not looking good. So variadic list. Can we search for it? Okay, so Control K also? No. Changelog, right. There's a changelog that mentions variadic list here. I want to see what type this is. Variadic list. No, this is not what we're looking for either. Dude, why is it not documented anywhere? Like, I can't even click on it. I mean, my assumption is that this is just a list, right? So import from sys.arg, import argv. So this should just be something like argv, then 0, right? Oh no, it's a function. Oh, it's a function. Oh my god, that was a function that returns the list. I'm such an idiot. So what does argv do again? I am such a freaking idiot. The list of command line arguments. it's a function instead of... I was thinking of Python, and in Python sys.argv is kind of like a list of strings, and the stuff inside the list is obviously the arguments that you pass into your program, but this is a function. That's interesting. So yeah, let's do that. So let arg. So if len works here, arg. Yeah. So if lens of args is less than 1 or less than 2, it's always going to be 1, right? So expect the type not a value. What? So what does len return? Returns an integer. Cool, yeah. Oh, okay, cool. This is just a... right, how can we print? How can we do some sort of like printing an error or something like that? Need the number. Can we return like this? Expected this in the dictionary. print line. I'm confused now. I'm very confused. What does that mean? What? I am so confused. Let's go back to language basics. What are we doing? So it is just print. It's print and then... Ah, yeah. This is not Rust. I mean, although it looks like Rust, it's not Rust. There you go. Yeah, then we can uncomment these and then kind of put the n here, I guess. So n would be something like is this how you convert between types? Can't construct int from variadic list. Oh, sorry, yeah, args. The second one. No, can't construct that from a string ref value in let. Fn Fibonacci recursion int return n. Oh shit, that's a much better. Thank you, Jose. Obrigado. So what are you saying? You're saying that this is more idiomatic. This is also big though. So we have function Fibonacci recursion. Ah, okay, so you just put that in the... Yeah, okay, so you just made this into kind of like one branch here. That's fine. Cool. That's kind of the same as what we had here before, right? But in one line. I like yours though. I'm gonna keep yours. Thank you. Oh. There you go. Now type conversion, that's the thing. So cannot initialize int from this. So let's look at how you can do type conversion. I am missing out. I'm missing the documentation here for the actual like built-in types, unless I'm being an absolute idiot here and not realizing that it's somewhere else. It's conversion. Implicit type conversion. Some types include built-in type conversion, typecasting. For example, if you assign a number to a string, it creates the string 1 instead of a compiler error. That number is equal to string 1. Alright, so it just converts it into a string. Yeah, I mean that's implicit type conversion. Structs, parameterization, code comments, blocks. How do I convert? So let's see. How do I convert string ref to integer? 1 second. I could swear I heard someone knocking on my door, but I was clearly wrong. I am back now. So always try to search the docs first. You can find the A12 function which will convert string to int. No, I will not. I cannot find the docs. Like where in the docs is it? Like in decorators, modules and packages, I guess. Or where is it? So at least it's not obvious anyway. So algorithm, functional, module index, atomic, it's any type, defines any type trait. Conversion, there's no conversion mentioned on the modules that they have. Int implements the int class. Okay. Maybe on the string type. String. Wherever that is defined. So we have string ref here. Implemented traits. Yeah, I don't know what this guy is talking about, but like it's clearly not obvious if you search for the docs first. It's on the string. Okay, it's the one module we didn't check, basically. Nice. Okay. Yeah, let's do that. So A to all, we've got args 1 here. Is that gonna work now? Cannot call a function that may raise in a context that cannot raise. Okay, so we need to try and catch here. That's good. It's telling me what to do. So try this, right? And I guess it's the same as, is it catch or accept? Invalid argument or something, right? Now, is it gonna let me use n in here? It's not, right? I know variable here. So does it work like in Rust if I do n? No, it doesn't, right? Try doesn't return a value. I mean, Rust doesn't have this, but... And there you go. So that should do. We can't play this song, unfortunately. It will be copyright striked. Nice. Even though it's a really cool song. Right, so now we have hello, the hello binary here. Need a number, so hello 10. And you'll get us 55, right? So that's right. I want to compare it with my shit, so. Yeah, so 5 is not right. So 10. Oh no, it was 10 anyway, so. The first 300 Fibonacci numbers, right? So for 10 we have 55, cool. And then for 50, maybe that's why it was not working. Is it bigger than the integer representation, right? So this has to be bigger than like 4 billion. Yeah, it was bigger than like a simple 32-bit integer. So maybe big int is actually just a 32-bit integer. But what if we want something bigger, right? Let's see if we can find out on the documentation page on modules, right? So let's look into modules. That seems to be a good source of knowledge. And we have int, or just all the modules, right? Built-in modules. Int implements the int class. Let's see what this defines it as. These are Mojo built in, so you don't have to import them. It doesn't say like the precision of them, does it? Yeah, it does not say what the precision is, so. But is there like a big int or something like that? Big int, no. Or large integer. Implements the int literal class. What is the int literal? This type represents a static integer literal value with infinite precision. They can't be materialized at runtime and must be lowered to other int types like int, but allows for must be lowered to other int types like int, the only other int type available, but allow you for compile time operations that would overflow, right? I'm laughing at this, but it seems like int is the only literal type available, and it seems to me that it's a 32-bit integer because it seems to be wrapping around my values, but I don't know. I'm trying to find here whether we do have a bigger integer type, but I don't know. I don't think we do. IO provides utility for working with input and output. Nice. That's what we were looking for, by the way. So we've got print. Do we have read as well or something? So print no new line. And there is no read. Okay, there's no read here. Yeah, so we're gonna have to stick with int really. And I mean, the problem is it doesn't seem to be giving me the right values. Like hello 10 gives me that, and then but if I go to hello 15, it's 650, right? So 15 here. Like this is already, oh no, yeah, 610. Sorry, that's correct. And if I go down to 9 to 20, 23. Then 2A657, 2A657, so that's correct so far. They've got 29, which is 514229, 514229. Yeah, so that's correct. And then let's see, we go down to here, which this is 24 million, right? So 37. I don't know why these are in red. Is it because they are... Oh, cool, yeah, so they are products of primes only, it seems. Didn't know that. Anyway, so 37, we have that. So let's see. They've got 241, 241, yeah, cool. And another one that's a prime here, so product of primes. So 41. So we have a billion here. So we get into the billions. So this should still be representable by an integer. So 41, right? It's the one. So 1655041 at the end, yeah. So that's cool. Now 42 is where it might break, because if it's an integer, this is more than half of 4 billion, I think. So yeah, let's see that anyway. So 42. So 26, that still works, but does this one work? 43. So 433. Okay, so that still works actually. So does it ever break actually, or am I just 710? Right, cool. Now we have 50 here, which obviously didn't work. It didn't work. So I do wonder where it's breaking. So let's try 46, right? Let's try 46. So it's 183 and then 903 at the end. 183, 903. Now this might take a while, because this is starting to get to the problem where it's actually doing too many of the same calculations. We can solve that with a map, by the way. We're going to learn how to do a map in a second. So right, 183 and 903. So that still works. That still works. And this is a prime number, so this is an interesting one. So 47. It's just going to get longer and longer now, though. That's the thing. So yeah. That should take roughly twice as long as this, right? This song sucks. So 47, 297, 073, 297, 073. Yeah, so that still works. I mean, did 50 actually break? I can't remember now, to be honest. I mean, this is definitely more than what should be allowed on a 32-bit integer, right? So that's 2 billion. No, that's still 2 billion actually. So if it's unsigned, it will go to 4 billion or something, right? I believe so anyway. Let's see. So 2 to the 32 minus 1. That's the maximum value you can have in an unsigned integer. So 429. Yeah, so with it's gonna break right here, basically. So 429. So yeah, 48 wouldn't work, for example, right? By this logic. What am I doing? So hello 48. Why do I feel like I'm gonna get a copyright strike for this? So 48, it still works, so it's still... Yeah, so maybe I am wrong. Maybe this is not just a 32-bit integer. 976. 976, right? Let's try 50. So 50 is the one that didn't work. I'm just trying to figure out like what the precision for this integer is and whether or not it's a 32-bit integer. It doesn't seem to be anyway, because it's storing more than the maximum allowed value of a 32-bit integer unsigned number. Hey Matt, can you make a video? Let's prepare for a developer interview. I'll reply to that message in a bit. Okay, so 125.0.225. 125.0.25. 125. What? It works now. I don't understand. Maybe I was doing something different. Return n if n is less than. Ah, okay. Is that because I was returning 0 as 1? Yeah, I was returning this as 1. That's why it was. That's why it was wrong before. So Jose, you actually fixed the bug in my code. Thank you. Anyway, so let's apply a map on this and see if we can like memwise things. Back on this, so let's see if we can find the map anywhere. Map hash maybe hash table. There you go. When is the hash table trait? Hash table. So value struct through hash table. Do we not have a collection for that already? A dictionary that stores key value pairs. Yeah, we can use this one. So how do you run? Okay, same as Python basically. So var d is dictionary. So can we change inputs in this? It's mutable, I think. So we can have a dict here of string, oh no, int and then int, right? Yeah, let's do that. So return. Okay, now we do actually need to check if it's in there. So if we do, what's dict? Use of unknown declaration dict. Why is it? Oh yeah, dict like this, right? From collections, and we need to import collections. Right, now here we kind of have to return. So the previous, I don't know, fibs. We're just going to store things to this map here, basically. So previous. How do we see if a value is actually in a key of it? Prints 1, depop b, key element. So methods, we've got init, we've got get item, set item, contains. Okay, so I guess we can do kind of like something like this, like if n in prefibs, right? We can return prefibs n, right? And that is safe, right? I don't know. Dict parameter 0 has key element type, but no value int. What? I don't know what that means. I don't know what that means. Let's have a look. Can we do int key or something? Like, where is string key from? That's my... Know that until standard library types implement key element. You must create a custom wrapper to use these as keys. For example, the following string key. Yeah, okay, so they don't implement the key type. That's good to know. So we have to create, I guess, something like this for us to use. So and let's see what this is doing. So we just have to implement a trait, right? So int key element. Key element there. And what do we have? A variable s string. So we need a variable n int. Right, I don't know what in and out is, but yeah. I also have no idea what this heart thing means, but we will go with that for now. What is heart? Tell me what heart is. Transfer from a value of trivial register type, has no effect and can be removed. Okay, it gives me good stuff. So I guess it's like a move, right? So it's moving the element. That's part of the memory safety. We'll read that in a bit, I guess. We don't know what that is, yeah. So init string literal. No, we don't want this one. So hash. Alright, so we need to implement a hash function here for the integer. Oh. I guess we can just do... Wait, what is this hash function doing? So what does it do? So a hash table type using its underlying hash implementation. Parameters: t, any hashable type. Arguments: hashable, the input. This is confusing as hell though. Let me read the documentation, see if they've got anything here. Surely that's going to be in the hash. In the hash module here. Where is it? Built-in, maybe? Built-in function. I want to look at this one here. So hash, a hashable type using its underlying hash implementation. Yeah, that's what we just saw. A 64-bit integer hash based on the underlying type implementation. Can we just kind of... Can I just return the int then? Self.in. That's, you know, the easiest thing as possible. Self.in. Right, that's where it hashes to. If it has to be a 64-bit integer as a hash, then the value of it is enough, as far as I know. Self.in equals to other.in. Okay, and then we can have something like int key. So if n in operation is not yet supported, okay, so how do we do this? Again, let's look at collections. I feel like this is going to give me a copyright strike, but we'll leave it here. Because it's Studio Ghibli, so they always give me a copyright strike, no matter what. Right, dude, so what is it? Collections, anywhere? Hello? Collections. Dict. I know this is not the way to do this, but oh my god. Cannot implicitly convert int to type int key. So I guess that the answer here is to do a conversion, right? Let's see how we can do an implicit conversion. Maybe if we look at the structs documentation, we'll find it out. Because we want to implicitly convert an integer to a type integer key, right? A Mojo struct is a type, is a data structure that allows you to encapsulate fields, blah blah. Yeah, we know that, we know that. So structure definitions. I'm interested in knowing the initialization methods, special methods, the dunder one. Special methods or dunder methods such as init are predetermined method names that you can define in a struct to perform a special task. Although it's possible to call special methods with their method names, the point is that you never should because Mojo automatically invokes them in circumstances where they're needed. All right. Cool. I mean, do I have the value decorator? The value decorator, when you add the value decorator to a struct, Mojo will synthesize the essential lifecycle methods so your object provides full value semantics. Specifically, it generates the init and copy init and move init methods, which allow you to construct, copy, and move your struct type in a manner that's value, semantic, and compatible with Mojo's ownership model. Okay, good. I mean, we have more stuff here. I guess this is not gonna... In addition, wait, what's this? The in-out argument convention you already saw in init. This code also introduces the owned, which is another argument convention that ensures the argument has unique ownership of the value. Cool. What's in-out? For now, ignore in-out. It's an argument convention that declares self. Okay, I don't know what this is. There you go, in-out. The function receives a mutable reference. This means that the function can read and mutate the original, right? So borrowed. Okay, like Rust. The function receives an immutable reference. This means the function can read the original value. It is not a copy, but it cannot mutate it, modify it. Cool, right. So we can... That's not bad. Right, I'm not finding the documentation easily here for implicit conversion in Mojo. Register passable trivial. I mean, yeah. Kind of implicitly convert int to value int key in return. Yeah, but we don't have int key. We have int key now, right? Wait, how do I construct something in Mojo? How do I construct it in Mojo? So decorators, structs. Let's look at it again. And we have the init module here. My pair, print mine up first. Yeah, I don't see why this is not working, right? You know, it's self and owned. Ah, okay, I see. My bad. So let new fibs. We need to do something like this. So var is the same as previous fibs. It's not copyable because there's no copy in it. Oh gosh. Let's look at the copy in it. So we need to do something like this. So copy in it. Can I do a copy here? Like, is there a deep copy anywhere? Is there a deep copy? Collections, complex. Maybe we need to just search for a deep copy. Okay, that's not what I found in the text. So error, deep copy, variant, life's copy constructor. So copy init, when Mojo encounters an assignment operator, he tries to make a copy of the right hand side value by calling upon that type's copy constructor, the copy init method. Thus, this is the responsibility of the type author to implement copy init, so it returns a copy of the value. For example, my pet returns this. Cool, cool. So we can just do a, hopefully, a copy init here with the right spelling. So what is it? Copy init in out self. In out self existing. So int key. Ah, no, never mind, never mind. This is self. Dot n has to be existing. Dot n here. Right, and it has to return what? Nothing. Right, so what is the issue now? So dict key is not copyable because it has no copy in there. Oh, for God's sake. So can I implement a copy in it for this? Deep copy dict Mojo. Deep copy a dict in Python. No, this is Python, not Mojo. Does it really not implement the deep copy? So what is it, dict or something? Yeah, no, this is, there is no copy here. They're quite right. They are quite right. More Minecraft music, we don't want that. And there is no copy. There's no copy module either, is there, in this? Not as far as I know. Oh gosh, what's going on here? So I'm trying, basically what I want to do is like copy the dictionary to a new dictionary every time. Or I guess, right, I could in out that. Does it work like this? And then I can just also return just an integer here, right? And then if I say if int n in previous fibs, wait, what? What's the function that we used again? What is the function that we're using? Contains. Okay, so contains is there. I mean, they have a dunder method for contains, which will be like called with the in operator in Python, but they don't support the in operator. So I guess we just got it. Is this how you do it? You just got to you just got to put it here. Int n. If it contains that, then we can return prefibs. Kind of call function that may raise in a okay, yeah. There you go. We're getting better. Getting better at this, hopefully. So try. And again, we're going to use the same thing. So let var result equals 0. Result equals previous fibs. Except we haven't found anything here, so can we pass here? Yeah, we can pass. And then return that there. Right, that should do. I mean, I don't know why it was so difficult for us to figure out all this shit, but yeah, I guess it is what it is, right? Now if we do a Fibonacci of, I don't know, let's create a dictionary here. So var fibs is going to be just empty. What is a dict? And then we have int key and int there. Fibs there. Use of uninitialized value fibs. Okay, yeah, no worries. We can do that, right? Empty. Cannot emit dictionary literals yet. What the hell? How can we create dictionaries in Mojo then? Okay, just the empty constructor from the looks of it. Expected a type, not a value. No problem. There you go. Can we do Mojo build hello.fire? Build that. So now we can still hopefully do that. Hello 10, 55. Okay, so if we do 55 now, it should still be a lot quicker, right? It should be a lot quicker. Or maybe not. Maybe it isn't quicker. Yeah. Why is it not quicker? I mean, it should be caching the values and then just getting it from the dictionary instead, right? Ah, yes, of course. It's because we don't return it. You know, thank you guys for noticing this bug here. There you go. Oh, the fire. Right. We fixed it now, and we built it again, so. Nah, it's not any quicker. Why is that? Why is it not any quicker? Yeah, no, I'm not liking this. What I'm wondering is, like, why is it not actually getting it the hard way? Or recursing? So it's just recursing all the time, basically. So in key is never found for some reason. Like, if we do not found, what is going on here? There you go. So we didn't build. We have not build. So if we do Mojo build hello.fire and run hello 55 again. So we're not finding any of them, you see. Ah, yes. Of course we're not. is because we're not actually adding it in the first place. Another bug. Guys, I'm writing such buggy code all the time. I do apologize, but like usually I have more people here to tell me what I'm doing wrong, but that's the problem. Result is going to be if any more n is that, then we're going to do this. If it's not, so if now we can call it is more than that, so we basically just have to call this crap here. And then we do have to add prefibs. There you go. Now it should work, right? So what am I doing? So Mojo build hello.fire. There you go. There you go. That's my point. A lot faster now that we have the caching. And is it the right content? Let me see this. 55. We have 139, 445. 139, 445. Yeah, it looks right to me. But yeah, I mean, let's implement the same thing in C++ and see how well this compiles to. And I've purposely done kind of very silly things sometimes, so maybe you might figure out that I can just return the previous fibs here straight away, right? Instead of like getting a variable and doing that. I just want to see like how well the compiler would be at optimizing these things, maybe applying some return value optimization and that kind of stuff, some sort of like optimizations that are done in C++ and in Rust. And I want to, yeah, we'll time the builds, right? So we will do that. I mean, the problem is now it's very kind of not hard at all, because it becomes a very trivial problem. Even I can get the 1000th number and it will still work, if it makes sense. So yeah. Hydrate yourself, guys. Do you guys like my t-shirt, by the way? I got this from, I'm not sure if there's anyone watching this, but I'll tell you guys a little story. So when I was at uni, I got this shirt from one of the Microsoft booths that were at my university, because I signed up for this thing called the Microsoft, is a student partner or something. So that was cool. I was a Microsoft representative in at university, which basically means I got a couple of trips down to London for free, which was cool. And I got some free pizza. That was also cool. I went to a few talks. They weren't very interesting talks, to be honest. They were just mostly about like, yeah, this is us releasing Azure now, and you guys can host a website on Azure. You can do whatever. So they were kind of like just advertising Azure to us at the time in 2000 and I think it was like 2016, 2017. But our job was to basically go back to university, and we had a bunch of like Azure vouchers, and we were meant to go into every sort of computer science event and then just have like a little booth and then tell people to start using Azure. So it was basically Microsoft getting us to advertise for them for free. It was kind of, yeah. I mean, I got a bunch of free shit, so I can't complain. I got this shirt, which I still have after like God knows how many years, like 7-8 years now. So yeah, more than that actually. If I've been out of university for 6 years, and that was in my second year, yeah, this was literally 8 to 9 years ago. Good quality t-shirts, that's what I can say. Microsoft is giving out the right shit. But yeah, let's write the same program in C++, shall we? So let's do something very quickly. Okay, so we have this, and we're gonna create a real quick cmakeLists.txt where we just have the add executable here, fib, which will be main.cpp, and we probably should add the cmake minimum required just in case. So we're going to write the same program in C++ now and compare both of them and see how it does. Cool. So we have project here, Fibonacci, languages, CXX. Oh, CXX, not CSS. And yeah, let's add the main file here. So we have a function, so we have, we could do a long there, but let's actually include the cstd lib or something, which does have the standard uint, no, cstd int, sorry, c standard int. And we have unsigned 64-bit integers there, and then we call it Fibonacci. I mean, ideally, right, I would have some sort of like global map here for my stuff. That would be a stud map or something like that. That's my fibs. Can I make it? Is it going to initialize properly? Well, I don't really care at the moment. Let's just get this to work. So this function, what is it going to take? It's going to take the uint64t n, and then the previous Fibonacci numbers, right? So we have I guess the fibs, which will be stud map std uint. I don't like this. Let's just call let's get a using up here. Okay, do that, and then we have the fib cache fibs there. Fib cache as a reference because we're going to be changing this. We call it fibs, and then yeah, this is what we can do. So the stuff. So we can do if n is less than 2, we're simply gonna return n here. And this is quicker than the cache, right? Yeah, getting a value from the cache. So we're going to do that. And next thing we have to do is to check that we found our Fibonacci. Also found in the fibs. So fibs.find. We have n here. And if found is in the end, meaning we found it, we can kind of return found. I believe it's found like that. So what is this issue? Expected a, oh yeah. Notice for conversion from std pair. Okay, no worries. So we can do something like first here. That's gonna get the key value for me. Oh, sorry. The key value we want the second one, which is the value. And then obviously if it's not, now we can do something like return. Actually, we need to calculate the return here, right? So we need to get the result. So we're gonna get result equals, we have Fibonacci n minus 1 plus Fibonacci and minus 2, right? I believe that's how it is. And obviously we need to pass in the fibs as well here. There you go, nice and easy interview question for everyone who's watching this. They tend to ask Fibonacci numbers quite a lot in interviews. I don't know why. It's like one of the most stupid questions ever. And quite easy, to be honest, it doesn't really show anything. So Fibonacci, oh yeah. What have I done here? So Fibonacci. That should have been Fibonacci. There you go. And obviously we can insert it into the map. So fibs n is going to be equals result. And we return the result here. That's it. That is our Fibonacci number. And now we're going to write the main function that quickly gets the value given in. So int main, and here we do need an argc, which is going to be an integer, and a car star star argv here. I am definitely going to get a copyright strike for this, so let's move it away. Okay. You know, when the song is too good, that's a general rule you can use on YouTube or any sort of like streaming platforms. If you're on a copyright-free playlist and one of the songs sounds too good, you're probably going to get a copyright strike. So just skip it. Best thing you can do. Anyway, so if argc is less than 2, then we are going to say need the number. Let's include it here. Okay, and now we can get the number. So we need a to I long integer long a to l. There you go. What does this take? This takes a character star. Okay, so we can do something like, you know, our n. I mean, this doesn't return the error though, does it? So it returns... Yeah, this does not return the error. So you... A to LL. But anyway, let's ignore that error. We just want to see the performance. Which means this will make it for an unfair comparison between the assembly generated by this program and the Mojo one, but we'll take that into consideration, right? Anyway, so A to L arg v1 here. Okay, so assuming that we have that, we can simply now do a std cout, actually autoconst my fib is equals Fibonacci of n I guess we have fib cache here. Oh no, we already have that cache anyway, so it's fibs. Ooh. And we can just print out my fib there. So my fib. Yeah. We don't even need the return there. There you go. So we've written the same program in C++. Now let's try and compile this. So can we do a cmake configure? And let's go for Clang 17. I said 17, but it's on 14. What is the issue here, dude? What is the issue? Saying user bin Clang cannot compile a simple program. Why? It's not able to compile a test program with the output. Like, why? Let's select a different kit then. Why is it selecting Clang 14? I just selected Clang 17. Anyway, let's see if we can do GCC then, because gosh, this is difficult. Alright, this also didn't compile something. Error bad value for mtune syntax. I don't understand. What is the issue here? Wait, what are my compiler flags? Why is it being set with like random stuff to it? Why is it being set for ARM? Settings.json. What do I have? Ah, that's why. Because I had the freaking toolchain from the last video. That's why. Anyway, sorry about that. That should be better now, right? There you go. Let's build it. Yeah, we build it. Cool, but it's not quite release, right? So let's build it for release, which is what the Mojo is probably doing as well. So cmake build. I guess we can reconfigure here. So let's pass in the settings real quick. No, actually, let's set it here. So set cmake build type to release. Okay. Reconfigure and then build. Good. And we have fib here, right? And fib does work as well. Let's take a look. So build, and we have fib 10, 55, build a 55, and then cool. Seems to be working fine, right? Now, what doesn't work if I do something like this? Okay, so it just ignores the errors. That's, you know, take that in mind. But anyway, what I wanted to see is like, let's compare this whole thing here, and let's see what kind of source code we would get from like a Clang compilation, which shouldn't be that much. Shouldn't be that much at all. There you go. We get how many lines? We get 101 lines of assembly. Now let's compare the same thing for Mojo, right? So if I run the object dump into assembly there, and we can take a look at what the assembly was. Like at this point, I don't know why it's so much, but you know, from 100 lines to quite a lot more, shall we say. Bear in mind, this is doing like memory checks. This is doing all sorts of like, I guess, try and catch statements and stuff, like stack unwinding. But you know, it's quite a lot, and you can definitely see like the difference in time that this would take. Because if we do, is it time? Yeah. If we do time and then hello, which is a Fibonacci, and then we do something like, we found 10,000. It takes what? Wait. I want to run it a few times to see. So man time, what do we do here? P verbose choir version. Can we run time with a few like times basically? Terminal time command multiple times. That's what I want. One second, replying to a text. Yeah, so this is just going to tell me to wrap it around, there you go, do this. So okay, so can I time this? Let's see. If I do a for loop. For I in 1 to 10, I'm going to do hello to 10,000, 100,000 there, and we do done. So it does it 10 times, right? Now if I do it 50 times, okay. And if I time all of it, then time all of it. So it takes how long? CPU total system 19. Does it tell me? Does it not tell me what? Oh, okay. Command not found. There you go. Let's time this. Wait, what? Why is timing not work? How do you run the command multiple times? Why am I so stupid? Right, time, command, terminal. How to execute time X with a time delay for some seconds. No, I want a benchmark. Let me just benchmark this. Linux benchmarker command. Install anything though, unfortunately. Yeah, that time is what we were using before. We can do a perf, right? Okay, yeah, let's try perf. Okay, no, we can't. Perf start. How do we get perf running on Ubuntu? No, perf is not working still. Perf utility can find a Linux tools package. Has no installation candidate. What the hell? Dude, what if I just get this one? If you can find your kernel release by typing uname that -r. So I guess Microsoft Standard WSL is the one I need, but it's not here, so we don't have one. So WSL install Ubuntu 22.04 install perf. Wait, this guy is literally suggesting that you recompile your whole kernel. That you compile your whole kernel just to copy the perf tool. Yeah, we're gonna do that. We're gonna do that right now. You already have the compiler somewhere, right? The kernel somewhere, I think. Or maybe not. Maybe I don't. Let's clone the Linux kernel and then compile it, I guess. Flex and Bison, we do have those, I think. All of this so I can get you guys a proper performance comparison between the C++ and the Mojo application and see which one's going to be faster. You know, we know it's going to be the C++ one because we've already seen the whole assembly. But yeah, I mean, and just for a nice comparison, like we got all of that object dump out of the Mojo one, which was like way too much. We do get the same, right? When we don't get the same, right? When decompiling our Fibonacci application. And we're about to see that now. So object dump fib into assembly. Yeah, I mean, I can tell you it's a lot quicker. So I mean, it's still big, don't get me wrong. Like, this gives me a lot more binary, a lot more assembly than the Godbolt Compiler Explorer. But, you know, what do we have here? We have 500 lines compared to... And this is going to be embarrassing. 96,000 lines of assembly for the Mojo one. So, yeah. Anyway, so let's go into WSL2 kernel. And now it's just gonna make it, I guess. Make J8. Ah, no. We can just compile the tool itself. So we're gonna go into CD, tools, perf, make J8. And we have an error. What is the issue? Kernel ABI differs from the latest version. I include. Oh, really, dude? Flex is missing on the system, right? Yeah, there you go. Now we're just compiling perf so we can have that utility. Perf is just a tool that will, you know, benchmark your application. That's all. Good. And now we can kind of copy it to the bin, and we should have perf here. Yay, we do. Anyway, so now we should be able to run perf. Whatever it was, grep history, grep perf. That's the one here. If we run it from temp and then what is it? Mojo something, right? There you go, boys. We have something better. So it took it, you know, 10 runs. 10 runs is probably not enough. Let's do a few more. Let's do 100. 100 runs on 100,000 Fibonacci numbers, right? So you've got 16.25 milliseconds. Okay, and now let's do the same for our C++ Fibonacci, right? So all we gotta do here is run fib 10,000, right? It takes a lot longer, it seems, though. So maybe maybe we're wrong. So how many CPUs utilized? I don't really know how to read this, to be honest with you guys. So 36.53 millisecond or microsecond. That number of page faults, cycles, instructions. Yeah, I mean, it's a lot. It is like roughly half, but why is that? I'll probably say it's because it's a map and not an unordered map, right? But we can check that right now, to be honest. Yeah, we can try that. So if we set it to unordered map and we do unordered, yeah, I mean, that should hopefully improve things. So clean rebuild. We did build it again. I'm also not sure if I'm reading this correctly, to be honest. I mean, yeah, much better now. Still, Mojo is faster though. Mojo's faster. You can see. Yeah, impressed. Even though with all that bloat on the assembly, it still managed to do a better job at calculating the Fibonacci numbers and like caching them to a map than the C++ naive application did as well. But again, I'm not sure if I'm reading this correctly. Okay, we did 10 runs in one of them and 100 in the other. So let's let's do that now. Okay, yeah, never mind. We're back to square one here. So C++ is still faster. Yeah, I mean, what kind of makes me realize here is that like the more runs you do, like instead of 10 runs, you do 100 runs, is that eventually I think the processor is going to start kind of predicting what the program is going to do, right? Because that's what processors do to make things faster, by the way. So it is better at doing that for the C++ code than it is for the Mojo. Yeah, well, I had a heart attack for a second there. I thought Mojo was actually going to be faster than C++, when in fact I know it shouldn't have been. But yeah, but it's not that much more slow than C++ when you think about it. It's only like what 5 milliseconds more. I'm not sure if it's I think this is milliseconds, not microseconds, right? Microseconds would be really good. But anyway, it's a like only 50-odd%, not even that, faster than or slower than C++. So it's pretty good. It's not bad, actually. I'm pretty sure that Rust would be a bit closer to C++ though. We're not going to have time to do that in this stream, but yeah, that's what we would have in Rust anyway. Something like close or faster than C++. I don't know, depending on how you're writing this, because the C++, the Rust unordered maps or hash tables or hash maps are actually a lot faster than the C++ one. So yeah, it's a good thing to keep in mind. But anyway, now would I do Mojo again? I'm sure that probably not, because there's no one watching at the end of the stream, so it's not really something interesting to the viewers. But most importantly, I also didn't really see any like advantages of using Mojo over Python for machine learning at the moment. Like the syntax is pretty much the same, right? Except you do get some like type checking here. There's a type checking system, but there's still a lot of things to be implemented from the looks of it. Like int operators are not there, and then standard types not being able to be added as keys in the dictionary types, which is kind of annoying because you have to write a whole class just for you to be able to use it as a key type. A lot of those little things, really. And yeah, most importantly, like, I don't know, it feels like in Python, if you're using Python for machine learning, you can just make it fast by including the libraries, right, that you need, like TensorFlow, NumPy, or whatever. You're doing computer vision, then you include OpenCV, and you move down to basically the C level. So essentially you're running C code for the most part, and Python is just gluing things together. Now, yeah, we'll see how this takes off. I don't know. Right now, I don't really see a lot of benefit to using Mojo over Python. Like, because you're going to have to learn a new language. You're going to have to wait for things to be released. So, that's going to take some time. But yeah. Anyway, I hope you guys enjoyed the stream. I'm going to call it a day here because I need to pack up to be in Brighton tomorrow. But I'll see you guys again in maybe on Friday if I'm feeling like it. I'll be streaming on Friday. And yeah, if I don't see you guys, have a good week, and I hope to catch you on the weekend. Bye bye.